Good morning to one and all person here. I am Adesh, working as a professor at Department of Mechanical Engineering, Amateur University. Today's session, I will explain the basic principles of vapor absorption refrigeration system called as VARS system. We have two types of refrigeration system. One is vapor absorption refrigeration and another one is a vapor compression refrigeration system. Well, compared to vapor compression refrigeration system, we are moving to this vapor absorption refrigeration system that I will explain. Here, the main drawback of this vapor compression refrigeration system is the compressor. When you provide this compressor, it will consume more amount of mechanical work. Here, the compressor is compressing the vapor refrigerant and send the substance to the condenser at required pressure. So here we are maintaining high pressure fluid. The high pressure refrigerant enter inside the condenser. Because of latent heat of condensation, what will happen? The entire substance converted into liquid. This happened because of latent heat of condensation process. Now, at the end of the condenser, we have high pressure liquid refrigerant. That high pressure liquid refrigerant now enter inside the expansion device. When it enters inside the expansion device, the process of expansion valve is reducing the pressure. The pressure is getting reduced. So previously we have high pressure liquid refrigerant, right? Liquid refrigerant. When it passes through the expansion device, what will happen? We change it into low pressure, same liquid refrigerant. That low pressure liquid refrigerant enter inside the evaporator. When it enter inside the evaporator in the form of liquid, but at the end of the evaporator, you can expect the vapor. That vapor is a low pressure refrigerant vapor. How the phase change occurs? Because of latent heat of evaporation in the evaporator. The latent heat of evaporation process takes place in the evaporator. So we can convert the liquid into vapor. The phase change process takes place, liquid into vapor in the evaporator. Now, that vapor, that low pressure vapor again sent to the compressor and the cycle continues. So to compress the fluid, here we are using a compressor. It consumes more amount of power. That we can replace by the vapor absorption refrigeration system. Now I will explain the vapor absorption refrigeration system. How we are going to replace the compressor and adding other units. Instead of compressor, here observer, generator and pump are the major units used to replace the compressor. Now we can see how can we replace the compressor and attain the required pressure. Here the observer will observe the ammonia vapor. Okay, the ammonia vapor coming from the evaporator is absorbed by the weak solution. The weak solution contains water. That water can absorb more amount of ammonia. When the weak solution is in the cold form, it can able to absorb more amount of ammonia. If it is heated or the hot solution is coming inside, the absorber cannot absorb more amount of ammonia. So we are sending cold weak solution to the absorber. That is a first point. Once the absorber process over, we can attain the strong solution. The solution coming from the absorber is a strong solution. The strong solution is entering in the pump. By using the pump, we can increase the pressure. During the pumping process, what will happen? We can circulate the fluid as well as increase the pressure of the fluid. Now the high pressure fluid enter through the heat exchanger. To preheat the fluid, we are providing these types of heat exchangers, right? The preheated strong solution now enter inside the generator. Already in the generator, we are supplying the you are supplying heat, but we can add the heat using the waste heat, right? The waste heat available from other circuit can be connected to this generator. That reutilization of energy is happen in this generator. So these types of vapor absorption systems are used to reutilize the energy available in the flue gas or solar energy, right? So here we required heat. Why the heat is required means when you add the heat only, you can uh, drift off these vapor present in the substance. Here the strong solution have moisture content, right? Water particles as well as ammonia vapor. We want to separate the ammonia vapor and water particles. For that we are adding heat in the generator. So when you supply the heat, what will happen? The ammonia vapor drift out and the weak solution is collected in the bottom of this generator. The ammonia vapor drift through the analyzer and rectifier. The purpose of analyzer and rectifier is to cool the fluid as well as to separate the moisture content, right? Water particles present in the solution. Now, the pure vapor is passing to the condenser. The substance enter inside the condenser is a pure vapor, right? It is a high pressure ammonia vapor. Ammonia vapor enter inside the condenser. Now in the condenser, the condensation takes place similar to the vapor absorption system. Here latent heat of condensation will carried out. At the end of the condenser, you can attain the high pressure liquid ammonia. Now the high pressure liquid ammonia is enter inside the expansion device. There we can reduce the pressure. So you can attain low pressure liquid ammonia. Now the low pressure liquid ammonia is passed to the evaporator. There the latent heat of evaporation takes place. Finally the evaporated vapor is a low pressure vapor. So the low pressure vapor is again circulated to the observer. The low pressure vapor is a high concentration ammonia vapor. Okay, low pressure but high concentration ammonia vapor. That ammonia vapor is passed to the observer. Again, it is converted into strong solution. Like that, the entire process is completed in vapor absorption refrigeration system. For industrial purpose, we can use these types of vapor absorption refrigeration system. And the advantage is we can reutilize the waste heat from flue gas or from solar energy. Thank you.